Our next presentation comes from CoraDavies. Cora is a first-year master's student in forest science within the Forest and Rangeland Stewardship Department. And she knew she wanted to study forests and insects growing up in the Pacific Northwest and spending most of her childhood outdoors examining trees and insects. And the title of her presentation is Seeing the Forest for the Bees.
In Colorado, fire suppression has changed the structure of the forest. Without historic fire intervals, forest stands have grown dense. The increased stand density results in an increased risk of severe fires, much like the ones we saw throughout 2020. A solution to this problem is to thin the forest by removing trees to return the forest closer to its historical condition. In doing this, we often don't think about what it could be affecting. The effects of thinning on forest bee communities are poorly understood, but could be important for conservation of biodiversity and ecosystem services. To explore this gap in knowledge, I spent the summer capturing bees and measuring potentially correlated variables in the ponderosa pine dominant forest of the Colorado Front Range. I tested the hypotheses that 1, thin forests would have greater foraging resources for native bees, and that 2, the changes in forest foraging habitat would result in greater bee abundance and diversity. We found that floral abundance and floral species richness were greater at the thin sites compared to the non-thin sites. These differences in floral resources increased throughout the summer between the two site types. In the early summer, floral abundance was 150% greater at the thin sites, and by the summer's end was more than 600% greater. In total, I caught more than 1,400 bees from 5 families and approximately 33 genera containing more than 142 species. Pictured on the slide are the 3 most common genera I caught: bombus or bumblebees, lasioglossum, and osmia. The thin forest sites with greater floral resources had more bees captured. The species diversity of the native bees was also higher at these thin sites. The foraging resources available and the abundance and diversity of native bees was strongly correlated. This trend was strongest at the end of the summer when floral resources are generally more limited. At the beginning of the summer, there was 50% greater bee abundance in the thin sites compared to the end of the summer when it was over 350% greater. Our results so far suggest a couple things. First, forest thinning has significant impacts on floral resources. Second, bee assemblages are likely to respond to this variation, especially later in the summer. We conclude that forest thinning for ecological restoration in ponderosa pine habitats is likely to improve resources utilized by native bees and is associated with an increased bee abundance in the wildland-urban interface. These results could be used to help to inform and improve management decisions for conservation of biodiversity and ecosystem services.